to the next session of model number 4, which is centroid. In the previous sessions, we had solved many problems. That is, we had learned how to locate the centroid of given composite sections, and then various composite sections having a part of it to be removed out and then locate its centroid. Now, we shall try to locate the centroid with respect to the given axis in the figure itself. That is, you have to be very careful when you try to measure the centroid with respect to the given axis. If the given axis is not specified, then you have to choose the coordinate axis, that is the referral axis. You have that liberty, but if the axis is specified in the question, then you have to do it accordingly. So, let us see how this problem goes like. The problem goes like this. Determine centroid of the shaded area with reference to its apex. So, there is a triangle given. So, this is the figure or the lamina given, and we have to mark the shaded area, that is the regions which are not having any opening is the shaded area. Let me shade it first. So, this is the shaded area, and they have specified clearly that you have to determine the centroid with respect to its apex. So, if you observe this figure, we can see that there is a triangle in which we have to remove a circle, a rectangle and a semicircle. Okay? So, please be careful, and let me write the dimensions now. It is 160 mm. The radius of this semicircle is 40 mm, and this dimension is 60 mm. So, all these dimensions are 40 mm. So, these are the dimensions given for this particular shaded region or the triangle. So, in this triangle the shaded region is as marked, and the opening circle, rectangle and a semicircle, and these components have to be removed out, that is the area of these components should be written with a minus sign. What about the first step in determining the centroid? You have to look into a axis of symmetry, if any. We can say easily that one half is the mirror image of the other. It is having a symmetrical axis. Okay. Then the second step is try to write the coordinate axis or the reference axis, and the third step is you need to give the numbers or divide the components into different sections. So, here I can name the bigger triangle as component number 1, then this circle which has to be removed component 2, similarly this rectangle will be component 3, and at last this semicircle shall be component 4. So, there are how many components now? The triangle component 1, circle 2, the rectangle 3, and this semicircle 4. So, there are totally 4 components, and we need to remove component 2, 3 and 4 from component 1. Then only we will be able to determine the centroid of the shaded region or the shaded area as shown in figure. Okay. Now, let us write this axis as OY axis, and let this be OX axis. You need to measure it along this axis and this axis only. The advantage here is, since it is symmetrical about OY axis, the centroidal value x bar will be equal to 0. Okay, let me mention it. The shaded area of the triangle is symmetrical about YY axis. Therefore, x bar will be equal to 0. Okay. We need to only measure y bar with respect to the given axis. Fine. Writing the centroid of individual components, that is trying to locate the centroid of individual components first, then with the help of that write the table. That will give you a clear picture about location of the individual components with respect to the given axis, and at last using those values filled in the table, we have to substitute that in the formulas of x bar and y bar, and then calculate what is x bar and y bar. No necessity to calculate x bar since it is 0, because of the reason it is symmetrical, and let us only calculate y bar. Okay. Now, component 1. So, component 1 is a triangle. So, this is component 1 and the dimensions of this triangle are 160 mm is the base and the height is 240 mm. Okay. So, this is component 1. See, usually we were naming the components, okay, but in this problem let me not name, let me proceed with the component itself, component number 1, component 2, component 3, component 4. See, naming is done only for the convenience, okay. Just for a change, let me not name this, let me proceed with the component numbers. So, component 1, where does the centroid lie for component 1? Since it is a triangle, we know the centroid lies here, okay, and if this is the axis or the referral axis and if it is symmetrical about this axis, then we will not be having the value of x bar for individual component, okay. So, we will be able to measure only its y component, okay, and coming to its area, A1 is equal to half into base is 160 into its height 240, which will be equal to okay, let me not calculate it now, let me substitute it directly in the formula, which is mm square. Then writing its y component, that is h by 3, h is 240 mm divided by 3, which is equal to 80 mm. So, 240 by 3 is 80 mm, this is component 1. Now, we shall write component 2. So, which is component 2? It is a circle. Circle and the radius of the circle or the diameter, whatever is given. So, if you observe clearly, the diameter of this circle is given as 40 mm. But what about the radius? The radius will be 20 mm, half of it, okay. So, where do you locate the center of a circle? It exactly is located at center, okay. So, since we do not need the x component in this particular problem, we shall not write the x component of component 2, we shall only write the y component. So, what will be the y value? So, this y is nothing but half of 40, which shall be equal to 20. So, area A2 is equal to, what is the area of circle? It is pi r square. Pi r is 20 in pi into 20 square, but it should be written with a negative sign, because it has to be removed, that is why I am writing the minus sign. Now, writing its y component, it is nothing but equal to radius r, which is equal to 20 mm. I hope you have understood component 1, component 2. Similarly, we shall write the component 3 and component 4. Component 3 is nothing but a rectangle. So, where is the center of the rectangle located? Exactly at center, and the dimensions of this rectangle, it is 60 mm by 40 mm. Since we do not need to calculate x bar in this problem, we shall not locate its x component here. We shall only concentrate on locating its y component. Okay. So, we shall calculate area. A3 is equal to 60 into 40 mm square, but we need to write what? We need to write the negative sign because it is the part to be removed. Okay. So, minus 60 into 40 mm square, and its y component will be equal to half of 40. So, which is equal to 20 mm. This is component 3. Now, at last component 4. A4, sorry, which is component 4, a semicircle, and the radius of semicircle is given as 40 mm. Now, where do you locate the centroid of the semicircle? We know it has to be located along this axis where it is said to be symmetrical, and we know for this individual component there is no x bar. We need to only locate its y bar or the y component, which is denoted by y and which is given by 4r by 3 pi. Okay. So, area of component 4, since it is a semicircle, its area will be equal to pi r square by 2, and this part has to be removed out, hence we need to write minus sign. Minus pi into 40 square by 2 mm square, and then its y component is 4 into 40 by 3 pi mm. This is the y component of the component 4. Okay. Now, we need to measure all these components of y with respect to the given axis. Okay. Shall we write the table now? Yes, we shall proceed with the table. So, this is the table to be filled: component, area, x bar and y bar. What is component 1? So, component 1 is a triangle whose area is half into 160 into 240 mm square. What about the x bar column? So, the entire column should be made equal to 0 because it is symmetrical about y axis. What about its y component? That is nothing but y1 with respect to the given axis. From this axis, try to locate the center of component 1. So, it will be located somewhere here, which is equal to how much? H by 3. So, total H is how much? 240. 240 by 3 is 80. This is y1. Now, let us try to locate y2. The second component is circle, and the radius of this circle is 20 mm. Then coming to its area, pi into 20 square, but we have to write with a minus sign. Okay. No x component, coming to its y2 with respect to OX axis. We had tried to locate the centroid of this circle, individual component, but it has to be measured with respect to this axis. This is y2. So, this distance has to be calculated. So, what is this distance? From this point to this point will be equal to how much? So, we know total is 240, 240 minus 40 minus 20, correct? See, total is 240 and the distance from this point to this point is 40 and from this to this is 40 by 220. So, therefore, 240 minus 40 minus 20, or you can measure it with respect to the x axis. You can keep on adding this 40 until you reach this point and then add 20. You can do either ways. Okay. So, this y2 will be equal to 40 plus 40 plus 40 plus 40, 160 plus 40 by 2, that is which is equal to 180. 240 minus 40 is 200, 200 minus 40 by 2 is 20, that is 200 minus 20 is 180. We have obtained 180. Okay. So, it all depends on from which point you try to measure. Okay. Now, coming to the third component. Component 3 is the rectangle and its area is 60 into 40 mm square, no x component y. So, we had tried to locate its individual y, that is at this point, but it has to be measured with respect to this axis. So, this will be our y3. Okay. So, if this is y3, measure this. So, from this point to this point is 40, from here to here it is 40 and from here to here it is 40 by 2, that is 80 plus 40 by 2. Which is equal to 100. And we have left out this minus sign here, be careful. And at last the component 4. Component 4 is a semicircle. So, semicircle area is pi into, what is the radius of this semicircle? It is given as 40 mm. So, pi into 40 square by 2 with a minus sign, because it is to be removed. No x component, calculate its y4, which is equal to, see, the centroid of this individual component lies here. That was done in the previous step. Now, just measure it with respect to the given axis, that is y4. It is nothing but 4r by 3 pi. Now, we have completed the table. So, using these values, we have to substitute that in y bar formulas. I hope you have understood. Okay. Y bar is given by A1 Y1 plus A2 Y2 plus A3 Y3 plus A4 Y4 whole divided by A1 plus A2 plus A3 plus A4. Now we know what is A1, A2, A3, A4, Y1, Y2, Y3, Y4. Let us substitute. A1 is equal to half into 160 into 240 into its Y1 80 plus A2. A2 is pi into 20 square into its centroid Y2 is equal to 180 plus A3 minus 60 into 40 into Y3 100 plus A4. A4 is semicircle, that is minus of pi into 40 square by 2 into 4 into 40 by 3 pi. So, this is the numerator whole divided by A1 is half into 160 into 240 plus minus of pi into 20 square plus minus of 60 into 40 plus minus of pi into 40 square by 2. So, on substituting and calculating these values, you are going to get y bar is equal to 82.02 mm. So, this is the y bar value from O x axis, but in our problem they had given you with respect to the apex. You need to determine the centroid with respect to the apex. So, the apex of the triangle means this point. So, with respect to this point you need to measure the centroid or locate the centroid. Okay. That means you need to calculate this y bar or try to locate this with y bar with respect to this point. But we had taken this axis as a reference. We need to locate the centroid from this point, that is apex. So, that is given by, therefore, the centroid from the apex is equal to 240 minus 82.02 mm. This is equal to 157.98 mm. See, this sentence is very much important because it is given in the question. We have to write this sentence at last. Okay. So, what does this mean? You need to locate the centroid first. So, what is y bar? 82.02 with respect to point O, locate that at a distance of 82.2. So, somewhere at around this point we can locate its centroid G of x bar comma y bar. Centroid position is now determined or located. This is with respect to its x axis. Now, the measurement is very much important. See, whatever we have obtained is with respect to this axis, which is given by y bar, and that is equal to 82.02 mm. But they have asked us to determine the centroid with respect to the apex. So, that means what is the distance from this point to the centroid? That distance has to be written here. That is nothing but 240 minus y bar. Y bar is 82.02, which is equal to 240 minus 82.02 is equal to 157.98 mm. This needs to be calculated. Okay. So, the centroid position is not changed. You need to locate it with respect to this point, that is it, that is apex. We have calculated it with respect to the OX axis, but you need to write the distance with respect to its apex. That is what is mentioned in the question. I hope you have understood this. Okay? We shall move on to the next problem now. The problem goes like this. Okay. So, this is the shaded area given. Okay. Let me write the dimensions. The radius of this semicircle is given as 100 mm. This is equal to 250 mm and this is equal to 120 mm. Okay. So, in this problem, if you observe this figure clearly, we have the lamina of this shape, out of which we need to remove the semicircular portion. Fine. And then in this problem, they have asked us to determine the centroid with respect to the given axis as shown in figure. So, in this figure, OX and OY is already given. You need to measure the centroid or locate the centroid with respect to this axis. Now, what are the steps involved? The first step is look into any axis of symmetry. If you have any axis of symmetry, then we can easily say there is an axis of symmetry, that is there is a mirror image of one part. Okay. So, if you cut it along OX axis, it is symmetrical, yes or no? So, this figure is symmetrical about OX axis. Then what about the next step? Write the reference axis, that is already specified in the question or mentioned in the question. So, no need of writing it again. The third step is divide the components into number of known components whose centroidal values are known to you. Okay. First try to locate the centroids of individual components and then try to measure it with respect to the given axis or the given reference axis or the given coordinate axis. Okay. And then you need to fill the table, all the details should be written in the table and then substitute that in the x bar or y bar formulas. So, in this problem, since it is symmetrical about OX axis, what can we write? Can write the value of y bar will be equal to 0. There is no need to measure the y bar, since it is exactly the symmetrical axis. OX is exactly on the symmetrical axis. If OX was written here, then we could have obtained some value for y bar. Since it is exactly at the symmetrical axis, there is no need to write the y bar value, no need to measure y bar at all, it will be 0. Here we need to locate only the x components, that is calculate x bar. Okay. Now, we shall name these components. So, let this rectangle be component 1, triangle be component 2, and this semicircle which has to be removed shall be named as component 3. Okay. Now, let me name A, B, C, D, E. So, if you want to name this point F, it is already O. If this point needs to be marked, you can give a name like H. Okay. Now, it is just named only for the convenience. When we write the table, it will be helpful, that is it. Okay. Even without naming this, you can proceed. There is no restrictions on it. There is no rule that you need to write the namings also. You can proceed with the component numbers itself. Now, we shall proceed with the components. So, component 1. So, which is component 1? Component 1 is a rectangle. So, do we know the dimensions of the rectangle in this figure? We know it is 250 mm. What about this? Using this radius as 100 mm, so this will be 100 and this will be another 100. Total it will be 200 mm. Okay. So, component 1 is a rectangle A, B, D and E. It is 250 mm and this is 200 mm. So, where does the centroid lie? Here we need to locate it at exactly at center. And since it is symmetrical about this axis, we need not write the y component, only x component is sufficient. Okay. So, A1 is equal to 250 into 200 mm square and its x component is equal to 250 by 2, which is equal to 125 mm. This is the x component of component number 1. Now, component 2. It is a triangle. So, the dimensions are, this is 120 and this will be again 200, see 200, this is 200 mm. Now, we need to measure its x component only. We know that this x component lies somewhere here and that value is nothing but 120 by 3, that is x component. Okay. So, A2 is equal to half into 200 into 120 mm square. Then its x component is equal to 120 by 3, which is equal to 40 mm. Okay. So, component 1, component 2 is over. Now, component 3. So, component 3 is a semicircle. So, triangle BCD should be named. Now, coming to the semicircle, A, E point O this is F, the radius is 100 mm and this is also 100 mm. Okay. Next, this area A3 is given as pi into 100 square by 2 because it is a semicircle, and write a minus sign, and then its x component. X component is given as 4r by 3 pi. Area A3 should be written with a minus sign and x component is 4r by 3 pi. So, this is sufficient to write the table now. This is the table. X bar is measured with respect to OY axis and Y bar is measured with respect to OX axis. In this problem, what is 0? Since it is symmetrical about OX axis, Y bar is 0. We need to write only the X components with respect to the OY axis. So, component 1 is rectangle A, B, D, F, sorry E. Its area is 250 into 200, A1. Next, X1. So, we now know where exactly the centroid of this rectangle lies, and it has to be measured with respect to the OY axis, which gives us x1. So, if you look at the figure, you can easily say that x1 is equal to 250 by 2 equals to 125 mm. Now, coming to component 2, it is triangle BCD. Its area is half into 240 into 120. Then x2, measure it with respect to OY axis, but we had already tried to locate this for the individual component, but the same centroid has to be measured with respect to the OY axis. This is nothing but x2, which will be equal to 250 plus 120 by 3, which is equal to 250 plus 40, 290 mm. So, Y bar is 0. Next, coming to the last component, component 3, which is a semicircle AFE. Its radius is 100 mm. Its area minus pi into 100 square by 2, and x3 is equal to, so centroidal component of semicircle or component 3 with respect to this axis is nothing but x3. Okay. So, that is nothing but 4r by 3 pi. 4r by 3 pi. Now, we shall substitute this in x bar formula. A1 x1 plus A2 x2 plus A3 x3 whole divided by A1 plus A2 plus A3, which is equal to A1 is 250 into 200 into x1 is 125 plus A2 is half into 240 into 120 into x2 is 290 plus minus pi into 100 square by 2 into 4 r by 3 pi, 4 into 100 by 3 pi whole divided by 250 into 200 plus half into 240 into 120 plus minus of pi into 100 square by 2. So, after calculating and substituting the values of x bar, we get x bar equals to 195.79 mm. So, at last you have to write, therefore, g of x bar comma y bar is equal to 195.79 comma 0 mm. So, 195 so somewhere here this 195 can be located and x is 195.79 and y is 0. So, this is g of x bar comma y bar. Now, we can write easily this axis as xx axis and this as yy axis. This is how you try to locate the centroid and also calculate the centroidal values of given figure. Clear? We divided this into 3 components, component 1, component 2 and component 3. Component 1 is a rectangle, component 2 is a triangle, component 3 is a semicircle, and then we had tried to locate the centroids of the individual components and then try to measure those individual components with respect to the referral axis or the given axis, and then measure it with respect to the reference axis and then write the values as x1, y1, x2, y2, x3, y3 and so on. Then substitute that in the formulas of x bar or y bar. In this problem we have only x bar. So, we have substituted the values of a1, x1, a2, x2, a3, x3 and dividing it by a1 plus a2 plus a3, which is equal to 195.79. At last, please write this g of x bar comma y bar is equal to 195.79 comma 0 mm. Okay. So, after writing this, try to locate the same in the given figure. That completes the problem. Okay.